Assalamu alaikum. Today I will discuss about the equation of continuity, which is very basic equation of the fluid dynamics, and it is very useful in derivation of Bernoulli's equation, which we will derive in next lecture. So coming toward the definition, if we talk about the definition of the equation of continuity, it says that it says that the product of the cross-sectional area the cross-sectional area and the velocity of the fluid along a pipe remain constant remain constant which means that if we have a pipe of cross-sectional area A and fluid speed V at any point, it would be equal to a constant. I hope so I have cleared the definition. Now we will derive this equation. Before derivation, we have to assume 2 points. Number one, our fluid used is incompressible, which means that its density is a constant value, or its density doesn't change. And the second is the flow of the fluid is laminar. I hope so you know the turbulent flow and laminar flow. The laminar flow is smooth flow, like this one. The liquid flows or fluid flows without any disturbance. And if we talk about the turbulent flow, it's not a smooth flow, it's disturbing flow. For example, if a pipe is closed by some blocking, the flow of the liquid become turbulent. I'm showing a rough diagram. My drawing is not very good, so I'm sorry. Now coming toward the derivation, assume that we have a pipe with varying cross-sectional area like this. This. Suppose that at lower end the cross-sectional area is A1. The cross-sectional area is A1 and it's covering the length of the pipe equal to delta x1, and also suppose that here the speed is v1, and also suppose that So suppose that the area with dark shadow has cross section area A2 and is covering distance delta x2, and here the velocity is v2. We all are familiar with a very basic equation that density is equal to mass per volume. From this equation, if we want to find the mass of the fluid, mass will be equal to rho into volume, rho into volume. Uh, at lower end, the volume will be equal to cross sectional area A1 into delta x1. We may call this equation number 1, and if we apply the same equation on the upper end, then mass will be equal to rho into A2 into delta x2. We may call this equation 2. We may call this equation number 2, as their left sides are equal, so we can equate them. After equating equation 1 and 2, rho A1 delta x1 is equal to rho A2 delta x2. Density will cancel on the both sides, and density will be cancelled on both sides. The equation will become A1 delta x1 is equal to A2 delta x2. There is very basic equation in physics, S is equal to Vt. Here for lower end, S is equal to delta x1, velocity is equal to v1, and time to cover the distance delta x1 is delta t, and for the upper end we may write the equation in the form of this. For our facility, we will give this equation name 3. Put these values in equation 3. We will get A1 V1 delta T is equal to A2 V2 delta T. Delta T will cancel delta T, and our final equation is A1 V1 is equal to A2 V2, and this is very basic form of the equation of continuity. Actually, it tells us that if we choose any point on the pipe whose cross-sectional area is changing, and the velocity at that point, their product will be a constant value. Okay, if I hope so I have cleared the topic. If you have any confusion, you may ask in the comment box. Thank you.